Hey everyone, and welcome. Today we're going to tackle something that trips a lot of people up in math, algebra. But I promise we're going to break it all down and show you how it's actually a tool to make things way simpler and more powerful. So, here's the plan for today. We'll kick things off with the big question, why letters anyway? Then we'll cover the basic rules of the road, learn how to give our expressions a real value, clean up messy ones, and finally put it all together to solve for the unknown.
All right, let's just jump right in. Why on earth did the alphabet decide to crash our math party?
You know, if you've ever felt that way, trust me, you are not alone. But what if I told you these letters, or variables, aren't there to make things harder? They're actually there to help us. They're like little placeholders that let us see the big picture of a problem more clearly.
Okay, think about it like this. Let's say you're buying some snacks, but you haven't decided how many yet. Instead of just guessing, we can use the letter X to stand in for the number of snacks we don't know yet. This lets us build a neat little formula for the total cost. 601 for each of the X snacks. We just write that as 600X. See? We've captured the logic of the situation without needing to know all the numbers up front.
Okay, so if we're treating algebra like a new language, then it's gotta have some grammar, right? And these rules, well, they're all about making our math sentences, our expressions, as clean and easy to read as possible for everyone.
So, to make sure everyone's on the same page, mathematicians came up with a few simple rules of the road. It's kind of like a style guide. We ditch the multiplication signs to reduce clutter, we always put numbers before letters, and if you see a lonely X, it just means 1 times X. We also keep things tidy by writing letters in alphabetical order, and instead of writing X times X, we just use a neat little exponent. Finally, division just becomes a fraction. It's all just about making the language cleaner.
All right, first up, a key bit of vocab, the term. You can think of terms as the individual Lego bricks of an expression. A term can be a plain number, like 3, a variable, like y, or a number and variable stuck together, like 5x. These are our basic building blocks.
And what happens when you snap those Lego bricks, those terms, together with plus or minus signs? You get what's called a polynomial. So this whole thing, 5x minus 2y plus 3, is a polynomial. Heck, even a single term all by itself is technically a polynomial.
Okay, so now we know how to write these expressions. But what good are they if they're just letters? The next step is all about turning those letters back into actual solid numbers. The magic word here is substitution. Now it might sound a little fancy, but it's super simple. All it means is swapping out a letter for a number that we now know. We're just replacing that placeholder with its real value. Let's try one out. Take a look at this expression, 3x minus 1. Now, what if I told you that our unknown x is actually the number 2? What's the value of the whole thing? Simple. First, we just swap the x for a 2. And remember, 3x really means 3 times x, so our expression becomes 3 times 2 minus 1. From there, it's just basic math we all know how to do.
And boom, the answer is 5. Just like that, we took this abstract idea and found its real concrete value.
Sometimes these expressions can get pretty long and look, well, messy. So the next skill we need is learning how to simplify them. It's kind of like tidying up a cluttered room so you can actually see what you're working with. And here's the most important rule for simplifying. You can only combine like terms. What does that mean? Well, it means they have to have the exact same letter raised to the exact same power. So yeah, you can add 5x and 3x together, but you absolutely cannot combine 5x and 3x squared. They're different things. And any plain old numbers without letters, we call those constants, and they're always like terms with each other.
Okay, let's walk through this one. First things first, get rid of those parentheses. We multiply that 2 into both the 3x and the negative 1. That gives us 6x minus 2. Now step 2, we just gather our buddies together, group the x terms, and group the plain numbers. And finally, step 3, we combine them. 6x plus 2x gives us 8x, and negative 2 plus 3 gives us a positive 1. And look at that. Our long, messy expression is now a super simple 8x plus 1.
Okay, this is it. We have all the tools in our toolbox. We know how to write expressions, how to plug in values, and how to simplify. So now, let's put it all together for the main event, solving an equation to find out what that mystery letter actually is.
I want you to burn this next idea into your brain. It's the golden rule of algebra. An equation is like a perfectly balanced scale. That equals sign is the middle point. And to keep it balanced, whatever you do to one side, you have to do the exact same thing to the other. That's it. That's the secret to everything.
Now, real quick, it's good to know there are two flavors of these things. What we're focused on are equations. Think of an equation as a mystery novel. There's only one specific solution that makes it true. The other type is an identity, which is more like saying a cat is a cat. It's always true, no matter what. But today, we're detectives, and we're solving the mystery of the equation.
All right, let's solve this thing keeping our balanced scale in mind. First step, we distribute that 4, which gives us 4x plus 8 on the left. Step 2 is all about getting organized. We want all the x stuff on one side and all the plain numbers on the other. So we'll subtract x from both sides, and we'll subtract 8 from both sides. Step 3, we clean it up by combining our like terms. That leaves us with 3x equals -9. And for the final step, to get x all by itself, we just divide both sides by 3.
And there we have it, the solution. X equals -3. That is the one, the only number in the universe that makes our original equation true and keeps that scale perfectly balanced.
So when you think about it, what we've been doing here is so much more than just learning math rules. We've been learning a powerful system for thinking. Algebra gives you a way to take a messy problem, define what you don't know with a letter, and then follow a clear, logical path to find the answer. And that's a skill you can use absolutely everywhere. So I'll leave you with this. What's an unknown in your life that you could represent with a variable?